Welcome back, guys. JC here. I really enjoy building and flying these micro-sized multi-rotors. The one and only problem I have with them, though, is that they just don't have enough power. So I've always been in the pursuit of making these perform better, fly faster, and just make them overall more fun. The two ways to increase speed and handling is one, either increase the voltage, or two, decrease the weight. So this one here, just for example, we are looking at, well, let me place the video transmitter on top, a total of about 54 grams, which isn't too bad, but let's see if we can do a little better. Not only do I plan on decreasing the weight by using this and that, but as you may have guessed, I also plan on increasing the voltage with these 2-cell 300 milliamp batteries. Now the 300 milliamps, you can go higher probably. I haven't tested these to find out what I like. I usually buy a few different sizes, and you gotta find that happy median of flight time and performance. Now the frame kit, I'll go ahead and say that everything came off of Amazon. I didn't feel like shopping at like 3 different websites. And the links to all of these products will be in the description below, so you can find them there. I bought a 4-pack of these 2-cell 300 milliamp batteries. Now you can't just throw a 2-cell battery on a build. You actually have to make all the parts match and also be compatible with the 2-cell voltage. I just did a review on this brushed F3 Evo flight controller. You should be seeing the link in the corner of your screen or in the description below. It can handle a 2S LiPo. And it's not just the flight controller, you also need motors that can handle a 2S LiPo. Now I haven't tried these yet, so I can't tell you if they truly are rated for 2S, but what I can tell you is I've done a little research, and what I found was that apparently one of these store-bought cheap multi-rotors, there's one called a MJX X600, and it seems like that one uses 2-cell LiPo batteries, so the motors should be rated for 2S LiPos. And that's pretty much it as far as the things you have to consider other than your camera and video transmitter. So let's go ahead and open up this bag that came with the frame kit. Just get these parts out of the way. Wow, I'm actually impressed. It came with a lot of hardware. We've got some steel screws, some more steel, nylon, some longer ones, some shorter ones, some nuts, some nylon standoffs, and these things that will hold your motors in. Also comes with 2 Velcro pads. So the very first thing I'm going to do, like I said in the review for this flight controller, there's 3 pads, and you have to bridge 2 of the 3 to choose if you want to use a 2S or 1S LiPo. It actually comes pre-soldered on the 2 pads for the 1S selection. So I will remove this solder and bridge the 2 other pads to select 2S LiPo. Alright, so now I've removed the solder from those 3 pads, and then I added a drop of solder on the first 2 pads to select the 2S LiPo input. Now I'm just going to mount it onto this frame. To do this, you can use the supplied Velcro strips. I just really don't like these because they stick up too high, and it's probably more weight. I know it's not that much more weight, but hey, every gram counts. So what I'm using is this gel pad. I've already gone ahead and cut a little piece off to match the size of the flight controller, and then stick the flight controller to the frame. Now it's time to mount the motors. These motors actually came with these little plastic things on the end, so what I will do is just take these little clippers and take it off. Okay, the little plastic piece is off. Now I'm going to take some of these and go ahead and put one on the bottom. Alright, got the motors on. Now time to attach them. Just real quick, something I always do, you don't have to, but the motor with the red and blue wire, I always put on my front left motor, so pretend this is the front. Same thing for the rear right, and then black and white goes on the front right, rear left. Also, if you don't already know, the red wire is positive on the red and blue wires, and then on the black and white wires, the white is positive. Now, as far as attaching them, you have 3 different options. You can use pin headers like this, but I don't see a reason to. Not only do they take up more space, but they add more weight. The next 2 options is going to be either solder your wires directly to these motor output pins, or you can use these connectors. Now, this frame kit did not come with the female, well, technically male ends that these plug into. You can buy these separately. I get mine on eBay. They come in like packs of 10 and 20. But what you were looking for is JST 2-pin connector, 1.0 millimeter spacing. Just do a Google search for that. But like I said, you can cut these connectors off and just solder your wires on. And then the last tip, you'll see where it says M1, M2, M3, M4, 5, 6. You only want to connect these motors to 1, 2, 3, and 4. Skip 5 and 6 in the middles. Okay, shorten some of those connectors up and solder them directly to the pins. Now I can plug the motors in. One thing I forgot to mention, you should be seeing a picture on your screen now that actually shows which pins are positive and negative. I'll place a link to this in the description as well. You can now solder a battery lead onto your flight controller. Look at that chart to make sure you're getting positive and negative correct. Positive is closest to the inside of the board, negative on the outside. Now, the type of battery lead you use will depend on what kind of batteries you use. This frame kit actually came with a connector, but this one here is what you would use on your typical 1-cell battery. The 2-cell batteries are probably going to use this 2-wire JST connector. Or your battery might use something else, but whatever it uses, you will have to purchase separately that connector. The other tip I have is if you are using 2-cell batteries, don't use just any 2-wire JST connector. I mean, these are very generic. I mean, the pin spacing and all that is the same, but the gauge of wire is going to be different. Just for an example, here is the same exact 2-wire JST connector, but look at the difference in the thickness of wires. What I'm using here is 20 gauge, but I'd say 24 gauge or thicker will be fine. If you use something like this, it's just going to burn the wire up. Then place 2 rubber bands around the frame and flight controller to secure the flight controller. The gel pad, it is sticky, but it's not going to be sticky enough to keep your flight controller mounted to your frame. That's what the rubber bands are for. I only use the gel pad to remove the vibrations from my gyro sensors and also to keep the board from contacting the carbon fiber frame, which does conduct electricity. That was the point I was getting to. As for batteries, if you purchase ones like the ones that I have here, you'll notice that it has 2 balance leads. This is just so you can pick and choose which one you want to use for whatever type of parallel balance board you are using. But I already know that I need this connector and not this one. Also, this is pretty long. I mean, it's really not that much extra weight. It's probably not going to make a difference. I just prefer to shorten mine. So what I've done is completely taken the battery apart, removed the balance lead that I will not be using, shortened both of the wires, and then put it all back together and put heat shrink around the entire battery. I know that's a lot of work and it's really not worth that much, but it's just something I prefer doing. With these 1-cell batteries, they are so cheap that I really don't care about protecting the lifespan of the battery because I can always just buy more. I mean, I have like 30 of these things. So on these builds, usually I just fly it until it runs out of juice. With these 2-cell batteries, they're a little bit more expensive, so I want to protect the lifespan of the batteries and not over discharge these like I do with the 1-cell batteries. To do this, you can either place a buzzer on these buzzer pins, and then once we go on a clean flight, I'll show you how you can adjust your voltage warnings, and it will actually make your buzzer beep whenever your voltage gets low enough. Or the other thing you can do, and I find this to be a more accurate way of telling what your voltage is by using an on-screen display. So I just took a piece of double-sided foam tape or whatever, stuck it on, ran my transmit and receive. Now I just need to run power and ground to it. Well, I guess the third option would be not to use a OSD or buzzer if your receiver has telemetry. But I will be using this micro FRX receiver, and it does not. So that's why I need either on-screen display or buzzer. I mounted my video transmitter on top of this top plate and mounted this temporarily just so I could get the right measurements for the harnesses that I need. I trimmed them to the lengths that I needed, soldered them in place, and now we're here. Just some tips I have if you choose to use this camera. I mentioned this in all my other videos where I use this camera, but I'll say it again. Where these wires are pointing down, that's actually the bottom of the camera. So what I do is remove all the wires and flip them around to where they're facing up. This little speaker, I don't use audio, so I just completely remove it. Also, whenever I flip these wires around, I will not be using this harness because this video transmitter actually produces 3.3 volts that you can use to power your camera with. So I'll be using this harness to power the camera. And here it is, all said and done. A couple tips I forgot to mention. If you do use an on-screen display, place electrical tape on the top as well because you don't want the top of it contacting the carbon fiber because, like I said, carbon fiber does conduct electricity. And for this camera, I kind of just sat it down in this little cubby hole and it fit right in there, and then I just put a little bit of hot glue in there to hold it in place. But I also put electrical tape on the back side of it as well because I don't want the back side contacting the carbon fiber. For the receiver, I really didn't have anywhere else to put it, so I just put it on top of the video transmitter. Another tip, if you do use this micro FRX receiver, do not wire it 5 volt ground and your PPM signal to UART number 2. I mean, the ground and signal is fine, but the power, 5 volts is too much. It takes 3 to 3.5. Even though there isn't a dedicated 3 volt pin on this flight controller, you can use the 3 volts coming from the Spectrum satellite receiver. Before you plug in a battery, you always want to take a multimeter and do a continuity test on the main battery lead. If you are not seeing any continuity, then you should be safe to plug in a battery. Now the motors are going to spin because we haven't gone into Betaflight or clean flight yet. But join me in the next video where I completely walk you through it. That does it for this time, guys. So check the description below for the link to that video and also the last video where I did a review for the flight controller. But that's going to do it. So thanks for watching. Take it easy. I'll see you next time.